All right, I think we'll get started. Good morning, everyone. Thank you for joining us on the final day of Congress for this very important session, and I'm so thrilled at the speakers that we have for you today. So we are going to be speaking about generative AI, a topic which surprisingly hasn't been sort of bubbling to the top of the conversation at Congress, but there have been so many other important topics to discuss. I am Sarah Siegel. I am a partner at Deloitte, and I lead our healthcare practices globally. I'm based in the UK. I also lead our healthcare practice there, but by accent, you probably guessed I'm originally from the US. We are very, very blessed today to have three eminent panelists and speakers. We have Dr. Rohit Chandra, who's the Chief Digital Officer from the Cleveland Clinic. We have Dr. Michael Schlosser, who's SVP Care Transformation and Innovation from HCA Healthcare. And we have Dr. Tyson Wiesel, Group Chief Information Officer from MediClinic Group in Switzerland. So we have three incredibly eminent panelists who are experienced in this new and cutting-edge topic. And I'm going to let each of them speak for 10 minutes, introduce themselves, and talk a bit about their journey into generative AI with their organization. But first, just to ground the audience, I'm going to spend about 10 minutes just talking about what it is. Now, I know that there may be some of you in the audience who are deep into this, and there may be some of you who are just exploring it for the first time. So we thought it would just be good to do a little bit of a grounding so that we all have a common understanding. And we'll have plenty of time for questions as we go on. And I will just say we're going to test the power of technology by using the app in two different ways for questions in this session. So we thought we'd call this session Generative AI, What Comes First and How to Implement Safely, because those seem to be the two questions that bubble to the top when we speak to our clients about this topic. It's so large, it can be applied in so many ways. So the first step is a question which comes up often. And the safety issue is definitely a question which comes up often. How can we make sure that we are doing this in a way which improves patient care and doesn't put anything or anyone at risk? So I thought I would just start, as I said, by grounding us in what we're talking about today. Everyone's been speaking about generative AI a lot for the last sort of 6, 7, 8 months, but it didn't come out of nowhere. We've had different types of artificial intelligence for years, and many of you have probably been applying them in your organizations. We had machine learning, then we had deep learning, and only now have we come up with generative AI, which is really large language models. It is programs that have trained on billions and billions of data sets, and it is language-based. I think it's important to talk a little bit about this. It's not mathematical. If you ask ChatGPT to do a math problem, it might get it right, but it might get it wrong. So it is not about computation. It is about predictive analysis and making choices based on probabilistic outcomes. So the choice it makes won't be the same every time. And the key differentiator in generative AI compared to what we used to have is that it's capable of creating something new. When we used to have machine learning, deep learning, that's a good one, but that's not what I was talking about. There we go. I think we're there, thank you. There we go. It's able to create something new. So it's something that we didn't have before. Previously, our AI could help us come to an answer, make a recommendation, but it wasn't creating new content. And that is the thing that I think is one of the most sort of significant changes when we talk about generative AI. Excellent. So it has many different modalities or ways in which we can use it. Most of us have probably had a go at ChatGPT. Can I see a raise of hands if people have had a little play with it? Yeah, absolutely. I get it to write poems and fun speeches that I give with my teams at awards dinners and things. It's great for that. And it's really good at synthesizing text, at mimicking different styles. It can also code. I have an 8-year-old and a 12-year-old son, and when this all first started happening and I did my first training on Gen AI, I came home and I said, we're not teaching our kids coding anymore. Coding is dead. We can just tell generative AI what to code. It can code programs. A guy on my team asked it to code and create an app to do different things for it, and it did it. So it's really changing the skill set that we humans are required to have. Now, we need to check the code. We need to make sure it's right. But the sort of manual input and that sort of level is potentially no longer needed. It can create images. I have a friend who works in marketing and advertising, and he recently showed me a print campaign for a high-end whiskey that he was hired to do the promotion for. And it was beautiful. It was beautiful people on a beach at sunset, having a great time, and I just thought, oh, production value is really high. And he said this campaign was basically free. We didn't have to pay models, we didn't have to hire a photographer, we didn't have to fly anyone to a beautiful beach in Portugal. It's all computer generated. That changes a whole industry on its head. There's also video. So I was very blessed to be in an audience a few months ago when former President Obama spoke, and he had a fun fact but a scary fact. He said, because of the time when he became president of the US, because of the advent of smartphones, at a point in time, and he suspected it was still the truth, he was the most photographed and videoed human on the planet. And because of that, there's so much content of him, his voice, the way he moves, his face at every angle. There's so many deep fakes of him, and people send these deep fakes to him. And he says, you know, you and I, who have probably seen him on TV, might see these deep fakes and think that is actually him, talking, dancing, you know, what have you. He basically said, it's him and Michelle. You know, they can tell what's a deep fake and what's real. But beyond that, you know, the rest of us wouldn't be able to tell. Now that is hugely scary if you think about the implications for that. But all of that to say, you know, it makes videos. It also can create audio text. So every modality is pretty much covered. I haven't spoken yet about healthcare, but I'm sure that you've all begun to imagine the possibilities for healthcare with a technology that is this powerful. I won't belabor this slide on use cases, but I think it's really helpful to think about all of the different ways that generative AI can be applied to healthcare. So if you think about processes that have to be repeated over and over again, clinical coding, call centers that already rely on algorithms, diagnostics where we know that we can train machines to read images with high specificity, patient support. Imagine having a bot tailored to you and your medical needs that can check in on you, that can chat with you, that can seamlessly feed back to your primary care provider or hospital provider post-discharge. And then I think the final column is the most exciting. Think about the opportunities for care delivery. In some of the talks over the past few days, I've heard some of the speakers talk about their clinicians spending upwards of 50% of their time on clinical admin. No doctor, nurse, pharmacist wants to spend their day doing that. They want to spend their day with patients. This is a technology that allows them to do that. The other thing I think about a lot in this final category is translation. In England, where I work with the NHS, some providers have to have translation services for up to 35 languages because of the diversity of the populations which they serve. If somebody calls a non-urgent healthcare helpline, like we have a line called 111, sometimes they have to wait between 10 and 15 minutes to get the right person with the right language skills on the phone to translate for them. You know, that's a stressful period. Someone in your household, maybe yourself, is unwell. You don't know if they need to go to accident and emergency or if just a Tylenol will do. So the potential for transformation here is absolutely huge. Now, I'm really hopeful that some of our speakers will give us a few examples around some of these use cases that will really sort of excite us and delight us. Now, in my experience working with health systems around the world, this is where everyone starts. I have a problem that I could solve with generative AI. But people very quickly get to, wait, I can't just implement a use case. This is a big new field. There's a lot that I have to do around with it. So this page is sort of what I would say organizations need to think about around the use cases. You have to think about the strategy and investment that you're going to need to do. You have to think about the governance that you're going to put in place. And you have to think about the different ways in which you're going to execute this. Would you start with a use case of high clinical specificity? Would you start in cardiology? Would you start with a use case where there's great efficiency opportunity? You know, and how will you monitor these things? I will speak a little bit more about kind of ethics and privacy because these are regulatory concerns, but they're also concerns for leaders and organizations. So I would encourage all of you when thinking about generative AI and how you will apply it, not just to think about the exciting use cases from the previous slide, but how you're going to safely embed it in your organization. And that's what these principles are about. I've been asked to talk a little bit about navigating the regulatory landscape. I think this is quite interesting because this is a topic which is moving so fast. And when we speak to regulators, they are moving as fast as they can. But it's really a situation where organizations need to engage proactively with their regulators and be incredibly careful about what they are doing because they might be out ahead of regulation. I won't go through all of these different topics, but I might just highlight a few. So on the top right, we have software as a medical device. Any piece of software that you or a teammate or a contractor creates which aids in clinical decision-making is software as a medical device. And it's subject to a whole suite of regulation in most countries of the world that you might not be adhering to if you're not already a contract manufacturer of software as a medical device or hardware as a medical device. It's very stringent, and it requires a whole different skill set in terms of regulatory expertise. People are stumbling into this without knowing it. So that's why on the previous slide I speak so much about governance, because it's very easy to create, like a little bot or a little macro to help your clinicians out without realizing that you're going into a whole new area. People talk about how AI can hallucinate and make things up, and that's true, and that's another reason, again, for governance and the oversight that's required. So, all of this to say that there is a lot to consider here. And just because you might not think that you're falling under a regulatory regime, that's not a safe assumption. So I think it's important for people to be educated and proactive. And my favorite statement is, never assume, always ask. So just to close, because I'm really keen to get to our speakers, despite all of those cautionary tales, I really think this is such an exciting opportunity for healthcare. Think about the patient who has difficulty gaining access to services, or who needs services translated, or who has a lot of questions and can't get them answered. This provides the opportunity for a huge amount of tailored, specific care, and also the opportunity to share care pathways and journeys with family and friends who might not have that transparency today. Think about the clinician who is buried in clinical admin and doesn't want to be. This is the opportunity to solve for that. And think about our providers. I know in the UK, our hospitals run at 90+% occupancy. There's just not enough space, time, beds, operating theaters. This provides opportunities for increased efficiency, reduced variation in care, and lots of other improvements that will do well for the providers, but also for the patients and citizens in which they serve. So, with that primer, I'd like to invite our first resident expert, Dr. Michael Schlosser, to the stage.
Yeah, I think we're gonna, there we go. We're gonna stay in the seats just to be efficient. So, good morning, everyone. I'm Mike Schlosser. I'm the Senior Vice President for Care Transformation and Innovation at HCA Healthcare. I'm a neurosurgeon by background and have spent time in hospital operations and supply chain in the regulatory space working for the FDA, and now for the last 3 years have had the opportunity to lead care transformation for HCA Healthcare. Just briefly, for those who may not know, HCA Healthcare is the largest investor-owned health system in the United States. We have about 185 hospitals across 20 different states, take care of about 36 million different patients on any given year. Might see 10 million ER visits. So we're a large organization, diverse, do everything from small rural hospitals to large quaternary care facilities. And HCA really is known as an operating company. So we have exceeded at understanding how to manage and operate hospitals efficiently and effectively. And while we've always had a robust technology agenda and seen ourselves as being innovative, really in the last 3 years we've decided to make a bit of a shift, a step change in our strategy to really focus on how we can leverage advanced technology to accelerate our care delivery and improve outcomes, improve efficiency, improve the effectiveness of the care that we deliver. And so we launched this brand new strategy called Care Transformation and Innovation, which I have the privilege of getting to lead for the organization. And really what that is a purpose-built team. It's multidisciplinary, clinical, business, finance, technology, data science, change management, an entire team that gets to wake up every day thinking about how do we leverage technology to really improve the lives of our caregivers, improve the outcomes, the experience, the efficiency, and the effectiveness of care that we deliver. And so sometimes better to be lucky than good. We started this journey about 2.5 years ago, and then about a year ago, generative AI came on the scenes, and now we had a tool that really was going to help us massively accelerate this entire agenda. Because I believe healthcare really is about communication and information. As providers, we spend most of our time talking to patients, gleaning information from them, talking to other specialists, to other providers, searching for information in their past, searching for information about their disease state or the treatment options, and then a small percentage of the time sort of executing, making a decision, delivering a treatment, performing a surgery. And so if you think about the power of a large language model to be able to assist you in that entire first step of communicating, understanding, searching, synthesizing information, there's the potential for massive changes in the way that we deliver healthcare. And the idea that an AI assistant could make that step in the process of understanding information, finding it, summarizing it, surfacing it, delivering it to the right person at the right time, far more efficient and far more effective, could return healthcare providers to where they spend all of their time at the top of their license, really doing critical decision making, performing procedures, listening to their patients, communicating with their patients effectively. And so I think that future state of healthcare where AI has removed all of that administrative burden and returned us truly as healthcare providers focused on our patients could be dramatically different and better than the way we deliver healthcare currently. So, as I said, we were fortunate that we had this sort of purpose-built team already focused on figuring out what are the best opportunities and how do we deliver technology to solve some of those problems. And so we began 2.5 years ago to do this work and then really have started accelerating in the last 12 months. But as Sarah alluded to, we discovered there were really two critical first steps if you want to really deploy generative AI across an organization in a meaningful and impactful way. The first is data. And so never has it been more true than with generative AI, the phrase garbage in and garbage out. Because when you're training algorithms, that's true, but a lot of times you'll notice through the process of trying to train a deterministic algorithm that your data is not good and the outcomes you're getting are not great. Generative AI models are really great at taking garbage and turning into something that looks like it's meaningful and correct. And so you really have to have a strong data foundation and data structure in order to be able to leverage generative AI. You can go take some notes and drop them into ChatGPT and say, hey, summarize this for me, and it'll produce a pretty interesting outcome. But to be able to do that at scale and to operationalize that and have it really be an effective tool that clinicians can use broadly requires a really robust data structure with clean and quality data. So that's been our first initiative, is how do we take the data that we already are leveraging from our EHR and from multiple other systems and bring it into a cloud-based data structure, something we call a medallion architecture that allows us to organize that data in a way that Gen AI can take advantage of it. Step two was to stand up a responsible AI program across our entire enterprise. And I think this is incredibly important because these tools are very powerful, and I'm sure we'll get into some of the interesting stories about how powerful they are here today. But with that power comes responsibility. And so you have to have a structure in place to make sure that you're using models in a safe, an effective, a fair, an ethical, and a robust way, and have a structure that allows you to study each use case and ask those questions about what risks are we potentially incurring here, what risks do we have based on the data that we're using to feed the model or to train the model, based on the decisions people are going to make on the model. And I think the most challenging part is how do we manage and maintain these things over time? How do we assure that as we deploy a model out into the field for broad use, that we can keep track of what it's doing and the outputs that it's creating and make sure that it's not changing or drifting over time. So with those hurdles behind us, we have a few interesting use cases that I just want to touch on very briefly. The first one, and really these came from our providers. We asked our clinicians and providers, what are the biggest problems you want to solve or you would like us to solve? And not surprisingly, the clinicians and physicians all said documentation burden is number one. So The first thing that we did was start to deploy a solution where we could do ambient listening, listen to an ER doctor interview a patient, and use natural language processing and Gen AI to listen and transcribe that conversation and then turn it into structured documentation. And the structured documentation, I think, is the critical piece, and this is where the large language models have really been powerful, because it's not that hard to do ambient speech to create a transcript and then just create a free text note based on that transcript. But that's kind of going backwards, like if it's just all free text. Like we want good data, and so we are using the large language models to pull out the key data elements, the structured data elements, and then place them into the electronic health record in the right places. And so again, large language models have massively accelerated that work. It was very hard before they came onto the scene, and now we're using primarily Google's Palm and MedPalm to accelerate that work. And so that's the use case number one. Happy to talk about that more as we get into questions. The second one is really under the umbrella of what I would call a nurse assistant. And so the first use case inside that umbrella is a nurse handoff tool. So as occurs in all of your hospitals, at least twice a day, we have nurses handing off from one shift to the next. And that's an incredibly important and sometimes risky part of care delivery, because things can fall through the cracks. It's a very manual process. The tools inside the EHR tend to be very long and comprehensive and cumbersome to use. And so our nurses usually end up doing a lot of manual and handwritten steps in order to create a handoff to the next care team that's coming on. So that's a situation where we can train a large language model to read the EHR, read the last 12 hours of nurses' notes, physician notes, lab values, radiology and imaging findings, and then come up with a summary and a timeline of what happened and provide that to the nurse. But then also the power of the large language model is that they can be a human type interface to that tool, that the nurse can adjust that handoff if they want to. So the nurses can literally go in and type, for this patient, I really would like to understand the pain scores in more detail, so I can hand that off, and the large language model will go back and adjust the handoff tool to incorporate that feedback. I'll make one other important comment about that handoff tool, and that is the large language models, if you use them in sort of chatbot mode where you're asking them direct questions and you're asking them to generate answers basically based on their training data, really exposes you to the risk of hallucinations, because you're just hoping that the right answer is somewhere contained within that massive math equation that really is what a large language model is. On the other hand, they're really very good and very consistent if you give them a set of data like the EHR data and then constrain them to say, just use this as the complete source of truth. Don't go outside of what's in this data ontology that I've taught you, and give us all your answers based on that information. And then we've gone one step further with that handoff tool where we've said, and we want you to be able to show your work. So if you put something in the bedside shift report, be able to point to where that came from in the EHR. And if you do that, you can really limit the risk of hallucination. So the last example I'll give you is another one on that same theme, which is we've built a clinical labor management tool, a way of automating the staffing and scheduling of our nursing units. And that's a rules-based heuristic. We just put a bunch of data into a rules engine and it spits out really good schedules for each nursing unit. But we found that it got very, very complex when you were trying to float nurses and techs between different units with different skill sets and different requirements, maybe even float across an entire market. The rules became incredibly complicated to figure out how to do that efficiently. But what we discovered is you can teach a large language model the rules for an individual unit and teach it the data ontology that describes that unit, and then just show it all of the schedules, and it can actually figure out that next level of complexity. So we could show it an entire market and ask it a question like, what should we do about Friday nights? And the large language model could come up with answers of, well, float this nurse to here, offer overtime to this one, and that'll balance your schedule better. So again, an example where we're not asking the large language model really to generate new content, though they are generating recommendations, but we're teaching it a data ontology and then sort of constraining its answers to answer questions about that data ontology, and they're incredibly powerful at doing that. So I know I'm over time, but let me give you just three final thoughts, three final principles that we've used in deploying generative AI. So the first one, which I've hit a couple times, is don't ask the large language model to create facts for you out of nothing. They're much more powerful tools when you give them a universe of data and then ask them to interpret or solve problems within that universe of data. It's also a much safer way to use them to limit hallucinations. Administrative burden is a deep ocean of opportunity when it comes to healthcare delivery. And so for us, before we jump into ChatGTP as Dr. GTP, where it's providing diagnostic or therapeutic advice, we're going to focus a lot of time and energy on how do we use these as assistants to our caregivers to clean up all of the administrative processes, that 50% of their time that they're spending on non-patient value-added activities. Because then we'll return our caregivers to what they are best at doing, caring for patients, and we think that will rise all the boats, that will raise the tide for everyone. And then the last is, the hardest part of this is managing and measuring these things over time, so your ML operations. And so don't overlook the fact that just because you've built a tool and deployed it and it works, that you have to have a robust structure in place to continuously be monitoring that tool to ensure that your results aren't drifting, your outcomes aren't changing over time. That's going to become incredibly important as we go forward. So I'll stop there and turn it over to my colleagues.
That was incredible. Thank you. Can we go to Dr. Rohit Chandra next?
Hi, my name is Rohit Chandra. I'm the Chief Digital Officer at the Cleveland Clinic. And by way of background, the Cleveland Clinic, a little smaller than HCA, operates about 25 hospitals, 15 of them in Ohio in the US, half a dozen in Florida, and then a hospital in London and a hospital in Abu Dhabi. And by way of volume, I think we see roughly about 35,000 patients a day, over 1 million patients a year, and perform probably over 1,000 procedures a day. So my background is a little bit unusual. I'm actually a computer scientist by profession. I joined the Cleveland Clinic about 18 months back, and so I'm actually relatively new to healthcare compared to most of you. So I'll try and bring a little bit of some of that perspective when I think about generative AI. So unfortunately, we're at a place where we have to now distinguish between what I am forced to call classical AI versus generative AI. And as Sarah noted, machine learning and predictive analytics have been around, and actually in many of our everyday products, for over a decade. And in the last year, the world changed with generative AI. What is fascinating is the ability to generate text and content based on the massive amount of data that generative AI is trained on, and to be able to, I would say that all of us who've played with ChatGPT do notice an uncanny ability to extract information, to synthesize information, and to summarize it. And I think that that is going to change the human-machine interface going forward. It's going to change it for us as consumers. It's going to change it for us as enterprises. And I think we have to keep that in mind as we figure out how to leverage generative AI in any of our sort of day-to-day work. The other part that's fascinating about generative AI is the ability to maintain context from one request to the other. And the way that shows up is it enables you to have a conversation where it's not like you have to do a discrete, starting from scratch request each time. And that conversational ability is, again, remarkably powerful, because then you can imagine, again, the example that Sarah gave, which is how do you do a patient assistant or a physician assistant where you can actually have a conversation without having to reestablish the context with each new request. And these are capabilities that were much harder to get to with previous technologies. The third thing is that the tools to do any of this stuff or to apply these AI tools in your context are actually becoming a lot easier. So I think there is a world that we have to start thinking in terms of where AI becomes the platform for the capabilities that we build in our enterprises. So I think switching to different use cases, Sarah had a beautiful slide on sort of the breakdown of use cases, so I won't necessarily repeat those. But I will say there's both clinical and non-clinical use cases. I think that we're probably just scratching the surface of different scenarios. There are the obvious ones, like Michael noted, just the opportunity to do ambient listening, transcription, and chart summarization seems extremely powerful. A physician today spends several minutes before a patient appointment reading the chart, and that too, the chart itself is clunky and hard to navigate. If you can have generative AI generate a reasonably complete summary of that chart, you can reduce that time to 2 minutes. Physicians today spend anywhere from 60 to 90 minutes a day documenting every patient encounter that they had during the day. And ambient listening, transcription, summarization, generating a draft is within reach. And then you can imagine that a physician is literally spending just some time reviewing the draft that's generated, but then the bulk of the burden is then eased. A third use case that we're focusing on is in-basket messaging. For an increasing number of our patients, electronic messaging is, the usage of electronic messaging is increasing. It's going after more and more complex questions that patients have, and that obviously creates an administrative burden for us. And leveraging generative AI to say, can you sort, filter, and maybe even automatically respond to those messages is good for patient experience and good for us as caregivers. And then there's, I'll say, less obvious but administrative use cases. Michael alluded to the value of data. And a lot of data, there's obviously an EHR has a lot of structured data. That's the obvious category. The unstructured data has a lot of rich information, but it's usually not that easy to get to. And it's usually dirty, is the phrase that we've used in the past. But now with generative AI, I mean, NLP techniques have existed before, but now that these tools are becoming easier, you can actually extract meaningful information from the patient's chart and leverage it for predictive analytics, risk prediction, follow-up care, and eventually drive better patient safety and outcomes. So that use cases like that become interesting, where you're literally trying to do core plumbing in terms of enriching a patient's chart. A second example from an administrative perspective is, for every patient encounter for us, it goes through about 15 pairs of hands from start to finish. From registration to insurance information to pre-authorization to appointment, coding, claims, denials, payments, all of that. And one could imagine a world where all the paperwork gets digitized and the workflows get mostly automated, leveraging generative AI. If you look at the work that's involved in any of these, it's heavily manual, highly cumbersome, highly expensive, highly inefficient, sucks for patient experience, sucks for us as an organization, but one can imagine a world where these workflows are mostly automated and drive much greater efficiency. For patients, today their healthcare starts with, for most people, with a Google search. And you could imagine a alternate universe where you actually have a generative AI agent that knows about you, that's highly knowledgeable. The meme is it has passed a board medical licensing exam, putting that aside, but you can imagine highly sophisticated guidance that can actually be a much better starting point for patient care. I think it's fair to note that we don't know how much of an impact generative AI will make in any of these use cases, but the opportunity is huge. And that's how we approach it. I think the promise is it should enable us to provide better care to patients at lower cost and at greater scale. Touching on some of the buts, because with any new technology, there's always buts. I think generative AI is in its early stages. I think that we don't have a solid measure of its safety, its quality, its accuracy. All we have are empirical measures and anecdotal evidence. So it's very appealing when you start, but to actually use it in a production setting, today we don't have good measures for how well it's working. And we don't have systematic methodologies that when it's performing poorly, what is the playbook for improving its performance? And that could be, do you train it with more data? Do you prompt engineer it? Do you constrain it to the data that you only want to give it access to, so on and so forth? All of those are questions and design patterns that are still to be learned. I think it's fair to say that at this stage, while the technology is promising, I think we have more questions than answers. The other thing to keep in mind, I think, is that the technology is great, but in healthcare, we have to keep an eye on, we have to solve for healthcare, and healthcare is about culture, process, and people. So to my comment earlier that this is going to change the human-machine interface, I think we have to be thoughtful about how we design it. How does the technology show up? What are the adjustments to the processes that people have to adopt? We have to be super thoughtful and mindful, because otherwise there's a chance that you can actually cause more harm than good. The approach that we're taking at the clinic is twofold. One part is literally internal exploration. We've given our physicians access to sort of a enterprise instance of ChatGPT, and the goal there is literally to allow people to experiment in a variety of different use cases. And the goal there is to learn how ChatGPT performs out of the box. What can you do with prompt engineering? What can you do with additional data and training? And we want to make sure that we are as cognizant about the good, the bad, the ugly of the technology in different use cases. The second part of it is when we go after some of the big use cases that I think are compelling to the industry at large, we want to make sure that we are working with the right technology partners. And there we need to make a couple of adjustments. Because the technology is pretty immature and it's early stages, we're literally not trying to pick mature products. We're trying to pick sort of the right partners that we can co-develop products with. And that's a different mindset. We have to make sure that within the organization, we are literally thinking in terms of co-development as opposed to buying mature products. And because the technology is moving so rapidly, we have to kind of keep pace with it. So trying to figure out how we organize ourselves with conducting multiple experiments, multiple pilots that are well-defined, where we can learn, figure out who we want to sort of work most closely with and have good pass-fail criteria, is a second consideration when we go after some of these bigger use cases. So popping back up, I would say I think the potential for transformation is huge. I think that we will look back and say that this changed everything, but trying to figure out what problems and what that journey is something that's ahead of us.
That was also amazing. Thank you very much, Dr. Chandra. And finally, we have Dr. Tyson Welzell.
Hi. Is this on? Yes. Good morning still. Okay. Tyson Welzell, background as well as an emergency physician, further specialization in clinical epidemiology and disaster medicine, and now operate as the Chief Innovation Officer for Mediclinic Group. Just briefly that you understand perhaps the context of my talk, we operate in a whole series of countries. So we've got 79 acute and subacute hospitals and something like 46 clinics in South Africa, Namibia, the UAE, Switzerland, and we have a 29.9% share in Spire Health in the UK. So we operate internationally across a number of jurisdictions, a whole series of different data regulations, and within all of that we want to implement generative AI. So it's a fantastic situation to be in, and we've had some absolutely phenomenal talks, beautiful overview by Sarah, and brilliant talks by Michael and Rohit, and ironically, if I didn't change mine now, it would sound very, very similar to Michael's talk, because I think we're all facing exactly the same challenges. So I'm going to take it one level higher up, and that's whenever you're dealing with something new, as a management team, you want to start sighing, because immediately comes a massive change management component that you will have to roll across your organization. And the one big difference here is that the major marketing that was basically came for free internationally around generative AI was actually something we had to grapple with very, very rapidly, because on the one hand, you've got your managers coming and saying, fantastic, we need this now. This is going to solve all our problems, and here are the following outputs we want in dashboards, and everything's going to be managed by it. And on the other hand, you've got your clinicians who basically are clinicians, I was one myself, who say, absolutely not. Where are the randomized control trials? Where's the long-term evidence? Why are we doing this? Please stay away from me. So and I sort of sit in the middle because I've got data and digital transformation and innovation and clinical research reporting to me. So you sort of sit there and you go like, that's great. Let's get these parties talking to each other. And so the first thing is you don't need to start the conversation. The conversation is there. That's already, I think, the first thing. The second point is that we had to start a very major, shall we call it, conversation across the entire organization just to get basic education on what does this mean actually for us now and in the future. And so I can just echo the points that were made. This is early days for generative AI in clinician and nurse and patient-facing applications. At the moment, most of these instances are actually not reliable enough to be implemented. It doesn't mean it won't be in the future. It doesn't mean that we're taking jobs away at this point, but it means it's something we really have to grapple with and employ. And there I come immediately to my second point. If I look at some of my colleagues in some other organizations, their first response was, we will ban this in our organization. It's fantastic. So, of course, my immediate response was, how successful were you when you banned Facebook or Instagram within your networks? It doesn't work, okay? So rather than banning it and therefore thinking you're risk managing this new phenomenon in your organization, actually do what was described. You need to start setting up governance networks, start setting these conversations up, that individuals start understanding what can this do and what can't it do? And what can we do within our own organization? Because that's the most critical bit. And then the third part really is, and I can just, again, echo what was said, is the data. And I just want to perhaps drive this point a little bit further, because we actually had to go back and start from scratch to really start leveraging across multiple countries. And what I mean with this is, if you think about your own intranets, and you think what's on your own intranet, I mean, some of the stuff there is scary. It is not contemporaneous. It is of a different era. And now to think, if you let a generative AI algorithm loose, training on that data set, what the outputs might be, that's even super scary. So what you actually need to start off with is engaging with every department and every function within your organization, saying, guys, let's start with cleaning up what we're actually referring to and what we're referencing. And let's look back at our data sets, because invariably, once you now start looking, there is a tendency within organizations for databases to get babies, and those babies to have further babies. So what you're ending up is so many different data sets floating around the organization that don't speak to each other anymore. And if you now, again, want to plonk a generative AI algorithm on top of that, you're going to end up with very, very dangerous outputs. So we pursued a dual strategy. Firstly, we recognize the fact that the need is the same across the board. Individuals want to reduce administrative burdens. We've got overworked doctors and overworked nurses. We've got a very dry pipeline in many instances leading into this. So yes, we will have to embrace it. We will have to implement it. So in the interim, we have accelerated our activities around RPA and IPA to actually push those as much as we can in terms of relieving administrative burdens. But we've actually gone and implemented a total relook at our data structure across the organization, and actually said, how many of these databases can we simplify so that we can end up with a structure that allows us to do federated learning across our organization internationally, while still complying with all the data regulations that exist in the Middle East and in Europe and in Southern Africa. And that's a huge task. So what we're doing is we're satisfying the demand on the one hand, but at the same time preparing ourselves very much for the future. And with that, it allows the organization internally to actually grow into the task. And what I mean with that is set up those ethical AI boards that will be multidisciplinary. So we'll include nurses, we'll include patient representatives, we'll include doctors, we'll include administrators, to actually start having that conversation around what those outputs mean to them and where we would have a useful and safe application of that data. On the background, from a clinical research strategy point of view, we're actively pushing that we treat these training or rather modified algorithms like any other clinical trial, and therefore actually do the randomized controlled trial to look that the outputs are safe and applicable, and therefore we can actually register the output as software as a medical device. And that sort of brings me to the other major point, which is, and it was said, I'm just sort of re-emphasizing it, nothing out of the box is useful at the moment within our systems, nothing. So this whole idea of some company offering you a generative AI product and you can just plug it in, doesn't exist, sorry. So what you will end up doing, and this is sort of the approach we're following at the moment, it will be a multi-hybrid approach. So what you've got is you've got some of these sets that are trained on what we see in the ChatGPT type setup, and then you will have further models which you're then training actually functional, as mentioned, even ward specific, and you will then use combinations of these to drive output going forward, therefore allowing on the one hand the data safety point of view from our own side, meaning I don't have my sort of company confidential data leaking into other generative models outside, but at the same time ensuring that I don't miss out on what was trained in a large data community. Plus, it makes it incredibly more applicable to the application where we're actually using it down the line. And the way we've been approaching it, we've actually been saying exactly the same thing. Easiest and most advanced actually is computer vision. So let's see how we can actually get computer vision into our various clinical setups. Second point would be from a risk aspect. Let's see how we can apply this in the back office first, and then gradually work our way up into the more risky and applicable areas, which are generally directly patient-facing and client-facing. And so, just as an add-on for the use cases, we've got exactly the same. But again, the possibilities become quite interesting, and the fight we generally have is between legal and what we can do. So, for example, in the ambient clinical listening model, we're actually currently running a trial where, on consent, we're actually even saving the audio clips and allowing through open notes the patient to actually rehear those audio clips, which suddenly has shown a massive increase in understanding of what that physician-patient interaction was about, because we know how bad generally the understanding is in that high stress setup, and patients don't remember half of the stuff that they were actually told, and those patient leaflets don't necessarily go all the way to bridging that gap. So now we're giving the individual a further opportunity to not just review what is being said about them, but actually rehear that interaction, so that compliance improves, understanding improves, and if they've got difficulty, what we've even seen is that they then ask their partner or family member to then listen to this with them and reinterpret it. So it suddenly opens up fantastic opportunities, because on the basis of that, of course, we can give massive feedback to our clinicians as well in terms of what they are saying, how accurate they are, and everything around that, which is the part that gave legal a huge headache. And at the same time, really working our way towards what I would call the much higher risk environments, which are direct clinical decision support at a much more granular level, and actually shall we call it, almost prescriptive actions that the doctors might actually need to follow within certain clinical paths. Thank you.
Incredible. Thank you. Okay, that was incredible. Thank you all three so much. What we're going to do now is I'm just going to ask a few follow-up questions based on what our panelists have said, and then we're going to turn to some audience polling and questions. So please get your questions ready. So first of all, I think we've actually all touched on this topic sort of lightly and implicitly, but I want to really bring it out. Privacy. So Michael, you talked about creating a medallion architecture, bringing together just your data to use in these tools. Rohit, you spoke about an enterprise instance of ChatGPT. And Tyson, interestingly, you talked a little bit about kind of a hybrid model, didn't you? So, for those in the room who aren't clear, we cannot use the public instance of ChatGPT-4 in a clinical setting. So we have to think about the privacy elements of this. And I'd just love if maybe one or two of you could speak a little bit about how you've thought about that. And the second thing that comes to mind when I think about that is, wow, this is expensive. OpenAI spent $500 million developing, the most recent version of this. How have you done this? Who'd like to take a crack at that?
Sure,
Yeah.
I'll take a crack. And so, just in transparency, we did try to ban it first also. Like, that was what my IT department immediately did, was send out an email like, you cannot use this. And then we had to kind of talk them off the ledge. And first of all, that's not going to work. And second of all, we've got to figure out a way to leverage this technology to help our caregivers. But one of the main concerns, the reason why they sent that email in the first place, was privacy. That we were just worried that clinicians or anyone was going to take patient data and drop it into ChatGTP. And if you read the the privacy notice on ChatGTP, they do not say that they're going to protect that information. Now, they will tell you that they're not actively training the model based on the data you put into it, that it's a static-based model, but they do track and use the information that people put into prompts in different ways. And so we did have to immediately tell people, do not put patient data or any other sensitive HCA data into the online ChatGTP, because we can't guarantee that it's protected. So the first thing we had to do was figure out a way, okay, how do we enable people to use this in a safe way? And most of the companies, OpenAI and Microsoft and Google, have a way that you can create a secure portal directly into their systems, into the base model, where you do have all the right privacy rights laid out in the terms and conditions, so that they're not using any of the data that's put into the model for anything. It's all immediately deleted after that instance, that chat is done. And so you can do that. You just have to work directly with the owners of these base models to set up that agreement. But going a little bit further, that's kind of step one. You do want to be able to refine these models. That's one of the powerful things, is to create refined versions of models. And sometimes it's like Tyson was saying, it's a group of models together with sub-training. And so to us, we just had to sort of reinvigorate our thinking around HIPAA, which is the rules in the United States around how you have to protect patient data. Because now it's not just the data itself, which we already are pretty good at protecting, but it's the model that the data was trained on now has to be protected in the same way. And so we have to make sure that the model can't inadvertently expose a patient's data. If we've sub-trained a model on patient data, do we do it in a way that you couldn't go in and ask the model a question and it'll accidentally spit out information about Rohit because his data was in that model that was trained? So HIPAA already requires us to do that. It really isn't a change to the regulations, because we have to protect our patients' information in all forms. But we just had to add that to our responsible AI architecture, where we thought about, okay, what does that mean? If we have to be fully responsible for any output of any of these models, including their ability potentially to tell people about the patients inside, how do we protect that? How do we control it? And most of it comes down to being able to successfully de-identify the data. And that's part of this medallion architecture, is having these data products where you can use the data in a way that is powerful, but at the same time is appropriately de-identified. So it just comes back to, again, the data. Like, you have to have the right data infrastructure to support this work. And so regardless of what you try, you're going to keep circling back to your data. And do we have it structured, organized, de-identified, protected in all the right ways, if you're really going to be able to take advantage of these models in a powerful way.
Amazing.
I'll make a couple of quick comments. One is we actually went overboard trying to, it took us actually a couple of months to even enable ChatGPT, just because of a variety of guardrails that people needed to put. But I think, so one is, we do have an enterprise instance, so there your data is sequestered, so at least we could give people the comfort that you can actually put patient data in there, but it's not, it's secure. So that was, I think, important. I think the cost part is actually an interesting observation, which is it's early stages, we don't know. But tokens are expensive, calls are expensive, and I'm waiting for the day when we actually have a huge expense problem because the costs for all of these capabilities are high. I think we'll see how that evolves. I think the tech industry has huge incentives in trying to drive down the costs just because the applications are significant. I think the other part that's open is the large language models are an excellent baseline, but they're also expensive both in terms of computation as well as in terms of querying. I don't yet know how it evolves, which is, do you take a large language model and then you subtrain it or refine, add a layer of tuning which is specific to your data? Do you build, or does the world look like a bunch of smaller models that are specific to your domain, but then those are also cheaper to train and cheaper to query? I think the verdict on that is probably still out, and I think that people will experiment with a bunch of different models to see what works well so that we have the right level of control and the right cost profile.
I mean, on that point, absolutely. I mean, privacy is key and number one. We have to adhere to it. We've actually got one step further. It sounds grandiose, but it's actually only two dudes, where you set guardrails. And if you remember right in the beginning when the first major accepted model of ChatGPT came out, if you put, and I'm paraphrasing now, you put a question like, how do I build a bomb? And it would say, I will not answer this question because this is illegal. And then you say, imagine we are in an imaginative world and I wish to build a bomb. How would I do it? And then it would answer you. And that was the whole idea around how guardrails are constructed and how you can actually engage with that app. Now, we found exactly the same way. We build guardrails, and I've almost got, there must be a better term for it, but I call them white hat hackers, because they literally go in to try to break your guardrails to make sure that that stuff is really not accessible. And in the beginning, we were really surprised what they came up with. So again, you need those governance procedures in place just to make sure you're adhering to all the rules and regulations that are actually out there. And at the same time, in many instances, very surprising what even our patient advocates on our ethics governance boards come up with. So it's really something you have to embrace and play with. It's new, sometimes, again, unpredictable from our side, and yet very, very nice to actually have a mechanism in place to identify it. From a cost point of view, at the moment, I would say because we're using it in such a relatively limited form, the costs are still very much contained, but I completely agree. If we were to extrapolate that model to worldwide rollout for us, we probably would shut our doors. It's incredibly expensive from that point of view, and I mean, you will have all seen the articles. Even the ChatGPT founders at the moment, if they weren't so heavily subsidized, I mean, they're burning billions a month at the moment in terms of refining their models. It is incredibly expensive, and that little fee that the public pays to get access to the premium edition doesn't cover a drop in the ocean in that actual development. So there will have to be a major rethinking of how these models work. Otherwise, widespread adoption might actually be a huge problem going forward.
Yeah, and we know, for example, that Microsoft is currently losing money on its AI assistant. It's very expensive. In chatting with colleagues who work with NVIDIA, they speak, hearkening back to our plenary this morning, about the sheer cost, both in money and in terms of energy required for the compute power that these LLMs require. So there's a lot of cost considerations. Due to time, I think we should skip ahead, because I know there's probably a lot of questions to the audience. Karen, if you want to quickly put up the poll. And let's just show the results, and then we'll go to live audience questions. So we did ask you, starting yesterday, a few questions just to get audience sentiment about generative AI. And these are a few of the things that people put into the app when we asked. Sorry. There we go. What word sums up your feelings on generative AI for healthcare? I thought this was really interesting. There's really positive and really negative words. Quick responses from the panel to this.
That's what we're living.
Yeah.
That's what we live. Spot on.
Yeah, it's a very fast-moving topic, and I hope we have Ron in the room. Ron, we need to do this panel again next year and do this again and see what words we get. In Rio. With pleasure. Karen, can we look at the next question, please? And then we asked about opportunity. And I think, we've talked about this. This really reflects what we've seen from the panel today, especially the area around increased consistency and reduced variability of care. I think, the panelists definitely focused on clinical admin, which is where we see a lot of opportunity as well. And then looking at the downside, we asked one more question, which was about potential risk. And I think this is a very clear one. So, we see this a lot when media covers the topic. Are the bots going to take over? What's going to happen to healthcare processes? I mean, when I think about this, I think about the worldwide shortage in healthcare workforce. And I just think if this was a possibility, this would be so far away because we have so much more that we need to do in healthcare before we start running out of healthcare workers. But I'd be really keen to hear some thoughts from the panel on this sentiment. Rohit?
Coming from the technology industry, healthcare today scales by people. It's a human industry. And I think, I don't know the exact stats, but many, if not most people on the planet actually don't have access to quality healthcare. The only way that I think changes is if you can scale healthcare by leveraging technology for automation as much as possible so that at least you're able to adjust the scaling factors. So I think that has to be a long-term imperative. And I agree with all of the risks, but I think that those are sort of risks to be overcome because otherwise, the opportunity here is to be able to deliver quality healthcare to as many people as possible. And I think that that's where the potential for transformation is.
Absolutely. Yeah, Tyson.
I mean, the way I sell it, and I actually mean it, is that these tools actually allow our clinicians and our nurses to be human again. It's to free up the time to actually do what only they can do and a machine can't do. So if you look at productivity scores across multiple industries, healthcare unfortunately is one where productivity really hasn't improved at all, because you literally only have as much time in a day as you can see a patient. And these tools would ultimately, hopefully, lift that productivity so that with the same amount of workforce, you can be more human, you actually add that touch back to what we're doing in healthcare, and hopefully overcome a lot of the wasteful activities that a lot of our staff are engaged in, wasteful but necessary, unfortunately, and therefore overcome some of those gaps within the system.
Amazing. So I'd like to go to audience questions. Could you put your hand up if you have a question? I'm just trying to see how many we have. Okay, so what we're going to do is I'm going to take two at a time, and then I'll address them to the panel. To be fair, I'm going to start in the back. Could you say who you are and where you're from, please? And there's a roving mic coming to you.
Healthcare leader from Texas in the United States. And my question is about predicting outcomes. Do you, in the panel, see any progress in terms of estimating what an outcome could be for a certain patient, and then a measurement of the actual outcome, and then an alignment with payers, whether they're government payers or they're commercial payers, and meeting them in the middle to develop this artificial intelligence in a way that can help assess value at different areas of the patient journey?
Thank you. Okay, before we answer that, I'm going to take one more. Do we have a roving mic at another question? Maybe front row here?
Great conversation. My name is Ruben Raposo. I'm with a healthcare startup in the United States. My question is about, you talked about partner with technology vendors. Are you taking the same approach that you have in the past, whether it's cloud hosting or any kind of solution, whether it's Google, Microsoft, AWS? Are you taking that same approach with generative AI, or are you doing something different because of all the legal and ramifications of it? So,
Great question. Thanks, Ruben. Who'd like to take the predicting outcomes question?
I'll jump in on
Michael?
that since my colleagues don't want to. So there's a whole bunch wrapped up in that question, but I'm going to focus in on sort of that payer provider interaction, because we are incredibly bullish on this technology being able to become that independent sort of third party that could sit between us and the payers and adjudicate prior authorizations and claims, and to your point, like understand outcomes and even predict outcomes. The hurdle we have to get over there is a sort of political and change management one, not a technology one. So the technology is capable of doing that, and we've already built some models that are fully capable of understanding the chart and the medical necessity for admission, and neither side really disagrees. I think what we have right now is just inertia around the fact that the current model is working for the payers and providers. Doesn't work for the patient, but it works for the payers and providers in terms of we fight with each other, but in the end we both end up profitable. And so we have to break through that inertia and get to a point where we decide we want to solve this problem. We want to get rid of all of this waste in the system that's processing claims and denials and fighting denials. And there's got to be a compelling reason to go do that if we're going to be able to deploy this technology successfully. So it's not an issue of can the technology do it, it's how do we get alignment between the players to make it happen.
Tyson?
Yeah, perhaps just on that point, completely agree. It's political will in many instances. And of course, depending on the way your healthcare system is financed, the speed to effect will be quite different. So if you're in a fee-for-service environment, you might actually shoot yourself in the foot if the regulators now adopt this because of the efficiency directly coming back in terms of your remuneration. If you're in a DRG environment, general system improvements will actually drop the envelope of the DRG and therefore shift the system much faster as a whole. So the improvement by one large player can actually ripple across the entire system very quickly, because the others will have to adopt very quickly, otherwise they will be falling short. So the healthcare financing component is also quite important, but ultimately from an ethical point of view, of course, that's the direction we want to take. We want to reduce waste within the system.
Perfect. And Rohit, do you want to address the question about partners? I actually had this question too. Thanks for asking it, Ruben, because now you have to engage with really big corporations, right? Microsoft Nuance, Google Bard, NVIDIA, if you're buying GPUs, these aren't your traditional partners. How are you handling that?
So I think that big companies are obviously an important player, but a lot of the innovation in many of these emerging use cases, I think, is happening more in smaller companies than in larger companies. So I think our approach is twofold. One, actually, smaller companies move much faster because they live and die by this. So I think that's one part we're being explicit about. The second, when we engage with smaller companies, is smaller companies don't have 18 months to do an RFP and then who knows what. So I think that there we are trying to literally be deliberate and thoughtful about how do you actually design pilots and experiments that can enable us to co-develop and partner with companies that are moving at a much faster pace. So it requires us to actually energize our internal muscles differently and be willing to take risks.
I'm going to add just one comment there, because I think it's for us, it's not necessarily about the size of the company. It's the willingness to really partner on a deep level and to sort of marinate in our problems, spend time in the hospitals, talking to the caregivers, talking to the end users. I didn't mention before, but we have 2 Innovation Hub hospitals we've stood up to help do this work. And the purpose of that is we have to become obsessed with our end users, because I think, Tyson, you mentioned it, this is actually one giant change management project in the end. Like, that's where this whole thing lives and dies, is can you successfully drive the change management? And one of the ways to do that is to really involve your end users in the design of the products such that they see themselves in it and they can see the new workflows and adapt to those new workflows. So we'll work with small companies and we'll work with Google as long as they're willing to go to that depth of partnership where they're willing to iterate on the products. Again, nothing out of the box. One of the challenges sometimes we have with really small companies is that they're very focused on the next revenue and the next valuation, and they want that to just be employ the product we have right now so we can account for the recurring revenue that you've signed up for, and not spend 6 months rebuilding the product so that it solves the problem we want to solve. And so we're willing to work with anyone who's willing to kind of go in and help solve problems.
My short answer for that is actually hybrid. You have to work with everybody. So you will not necessarily now shift to a tiny little private cloud to do what you're doing. So you will work with your traditional players. You will want to get the more agile, more innovative, smaller companies in, and we've even got a third approach. I've got a drool-worthy, GPU-heavy server sitting in one of our rooms that all our geeks who don't like sunlight sit in, and they are competing with the guys from the outside who can get there first. So a lot of our innovation challenges are also now directly aimed at who gets there first and faster.
Actually, one additional comment I would add is, I think the large platform players are in the business of selling you technology and platforms, and that's distinct from health tech companies that are in the business of selling you healthcare products.
Amazing. I'm going to take 2 more questions. I think we have a mic here and here. Do you want to go first, sir?
Yes, I come from Brazil, and the city of Brasilia was built in the end of 50s in 4 years with large political decisions, and it worked, but it had many corruption problems, so risks. Telemedicine was not very keen for the physicians to adopt, but then came the pandemic. What to expect for AI to be fully accepted and regulated?
Thank you. Yes.
Yes, Dr. Aisha from the Abu Dhabi Department of Health and the United Arab Emirates. Just a question from a regulator perspective. What is your advice to us as regulators in healthcare in order to accommodate the vast and rapid change when it comes to utilization of innovation and technology in healthcare delivery, taking into consideration all of the related medico-legal aspects to be considered? Thank you.
We didn't plan that, but those 2 questions go very well together. Thank you both. Who would like to take the first crack?
I can try.
Tyson, please.
So just to mention something that you might not be aware of, so it's worse than you think. So there was an article literally yesterday that came out that there's now something called poison pixels, so that artists who are now fearing that their artwork is incorporated in large models and used for generating new artwork, they can actually use something called poison pixels, which will destroy the new model that you're actually building. And so, of course, that means immediately we're now concerned from a healthcare point of view that you could have poisoned data that actually is not spottable on the first sight, but could actually destroy your model down the line, which has huge repercussions. So yes, there's always a big risk in terms of are there unintended consequences? Are there issues around that? For me, it purely runs around trust. As healthcare providers, that's one of the major items we've got, and if we lose that, we are pretty much stuffed. So if we think back in the UK a couple of years ago, where one of the NHS trusts partnered with Google, and when it came out, there was a huge uproar because people said, but we weren't aware that our data is being reused in this instance. So the point is, if people are informed, if people give consent, if people are glad to be part of such an experiment, you maintain that trust, you keep them informed of the update until you're ready to roll something out. And that's the approach we've been following, because we want to be, and I'm sorry, I'm now giving our company byline, expertise you can trust. That's the key. If we lose that, we're gone. And so it has to be around information, consent, and rigorous risk mitigation along the line. So it's that it slows us down to a certain degree, but at the same time, it's the safer route to take, especially in healthcare.
Thank you, Tyson. I'm sorry to cut this short, but as we all know, IHF is a Swiss organization, and we have to run to time. And I wanted to save the last minute for what I've warned the panelists about, but I haven't given them the questions, which is my patented lightning round to close a panel. So the rules are, I would like you to try to answer in 1 word. If you can't do 1 word, 1 phrase. If you really can't do 1 phrase, 1 sentence. Okay? We're going to go Michael, Rohit, Tyson. Biggest hope for generative AI.
Operating at the top of your clinical license.
Rohit.
Transform healthcare through better care, lower cost.
Tyson.
Do more with fewer people.
Amazing. Biggest concern or fear with generative AI? Michael.
Loss of trust.
I think the inability of society to deal with the inevitable hiccups that will happen.
It's loss of trust.
Loss of trust. And final question, 1 thing that will surprise us all with generative AI.
It's way more powerful than they're letting you know.
Yeah. Exactly.
it'll take longer to impact everything than we think.
Skynet.
And with those scary and inspiring final comments, please thank our incredible panel.